They say she needs to slow down. The baddest thing around town. Hello guys, and today we're going to be talking about unknown lengths and scale factor. So the video today was only a very small portion of the actual video, because we're going to be looking into the unknown and then also looking at scale. When we're looking at something really close up, it might not look that bad, but when we zoom out, it might be quite daunting. So let's take a look at our objectives today. Our objectives are 7.2a, I can find unknown lengths of similar polygons, and 7.2b, I can use scale factor to dilate polygons on a coordinate grid. All right, so first part is going to be about unknown lengths. The second part is going to be about dilation. So let's first start off with finding unknown lengths of polygons that we know are similar. So we're given that triangle RST is similar to triangle UVW. So RST to UVW. Okay, so what we can do is set up a proportion. Remember, we need to keep the corresponding sides on top of each other. So we can say that 6 over x is equal to 7 over 35 because UV are the first two letters of the similarity statement for triangle UVW, and RS are the first two letters in the triangle RST. So we know that UV and RS are corresponding. So we say 6 over x equals 7 over 35. We can then cross multiply, and we get cross multiply, whoops, that was a horrible circle. We get 7x equals 210, 6 times 35. We divide by 7, and we get x is equal to 30 feet. So when we have similar polygons, it's important to make sure that we are getting the correct corresponding sides. And so it's not always going to be like, oh, the right side is the right side and the left side is the left side. Sometimes the shape might be rotated or reflected, and we have to be mindful of which sides are corresponding. So here, 35 inches is the long side and 17 inches is the short side of this rectangle. And here 15 inches is the long side and x is the short side. So let's make sure that we put the corresponding long sides of the rectangle that go over each other. So I'm going to say that 15 over 35 equals x over 17. And so then we can cross multiply. Let's try yellow. And let's try white. So we get 35x equals 255. 15 times 17 is 255. So 35x equals 255. We then solve for x like normal. So we're going to divide by 35. And we get that x is equal to 7.3 inches. So the key thing here is matching up the corresponding sides, making sure that we put the corresponding side of one polygon over the corresponding side of the other one equals another two pairs of corresponding sides. It's also important that the numerators are of the same shape and the denominators are of the same shape. So notice how 15 and x are both part of the smaller rectangle, whereas 35 and 17 are part of the bigger rectangle. So that's how we find unknown side lengths of similar polygons. We set up proportions. So now take a moment to answer this question. Which of the following is not a characteristic of similar polygons? And your answer should have been D, congruent side lengths. Remember, similar polygons have proportional sides, they have equal angle measures, and they have the same shape, but their side lengths are, you guessed it, proportional. Congruent polygons have congruent side lengths. Okay, so that was our unknown side lengths. Now into dilations. So we talked about dilations in 7.1, that it's a transformation that changes the size but not the shape of an object. Okay, and scale factor is the number you multiply by to get the dimensions of the new similar shape. So when we dilate and get bigger or smaller, the scale factor tells us how big or how small we get. Similar to a similarity ratio, a scale factor, if a scale factor is higher than 1, then the shape gets bigger. And if the scale factor is between 0 and 1, then the shape gets smaller. Scale factor is always a positive number. So we have a coordinate grid, and we need to find the coordinates of the vertices of triangle A prime, B prime, C prime. Remember, A prime, B prime, C prime means the transformation taken from ABC. And so before, it might be like we would translate it or reflect it or rotate it, but now we're going to dilate it. And so we are given that A is 1, 1, B is 1, 3, and C is 3, 1. And we're going to have the scale factor of 2. To do this, we're going to multiply 2 by all of the different coordinates. So it's going to be A is going to become 2, 2, B is going to become 2, 6, and C is going to become 6, 2. We multiply the coordinates of ABC by 2. So we get A prime as being 2, 2, B prime as being 2, 6, and C prime as being 6, 2. Also take note that the side lengths were multiplied by 2. AB has a length of 2, A prime B prime has a length of 4. So when you dilate, not only do you multiply the coordinates by whatever the scale factor is, but also the lengths of the sides end up being multiplied by that number as well. And also note that the angles remain the same. These are 45-degree angles, and angle A and angle A prime are 90-degree angles. So let's do one more. Find the coordinates of the vertices of triangle A prime, B prime, C prime after triangle ABC is dilated using the given scale factor. So here we're given, we're going to use blue this time. Here we're given A, B, and C. So A is 0, 0. B is 1, 2, 1, 2. And C is 5, 1. So we have this triangle. I'm going to make a horrible triangle. I'm going to draw my best. Oop, oop, oop. Decent. Well, pretty good. All right, and we have a scale factor of 2. So 2 times 0 and 0 is, hold on, let me change the color real quick. We're going to make it magenta. No, let's make it green. So A prime is going to, 0 times 2 is 0. 0 times 2 is 0. So A prime is still going to be 0, 0. B prime, so we have to multiply 1 by 2. So 1 times 2 is 2. 2 times 2 is 4. So 2, 4. B prime. And then C prime. First, find what the coordinate of C prime is going to be. All right, it is going to be 10, 2. So 10, 2, C prime. So those are the coordinates, and this would be the triangle, the green one. Come on, work with me, That was the best I could do, okay? Ugh. So that is A prime, B prime, C prime is a triangle that is twice the size of triangle ABC. In other words, looking like that. All right, so that's basically it. Finding unknown side lengths of similar polygons by creating proportions and creating dilated polygons by multiplying the scale factor by each of the coordinates.
Look up, smile, stand up straight, smile, with your breath, smile, look up, yes. Cause every girl here wanna be a, oh, she's a diva. I feel the same and I wanna meet her. They say she low down, it's just a room and I don't believe her. They say she needs to slow down, the baddest thing around.
Alright, go on and take the 7.2 online quiz. Good luck with that, and I'll see you in class soon. Bye-bye.